What's up, everybody? Josh Collins here. This will be my study guide video. I chose for the study guide video the laws of thermodynamics. And if you hear rumbling, there's actually a thunderstorm going on, which is kind of ironic once I get through my story. But if I look over here, obviously got all my notes, my little clipboard, so I can stay organized and keep on track for y'all. I chose the thermodynamics. I just think it's pretty cool, honestly. It's kind of like the coolest one, at least to me. And the first law of thermodynamics is a physical law that states that energy cannot be created or destroyed. The energy can only change from one form to another. The second law is a physical law that states that energy, every conversion of energy is not perfectly efficient and invariably includes the transformation of some energy to heat. So these are both physical laws. They both have names. I chose to do everything like straight out of the book. Those definitions are out of the book. There's actually 3 laws. But the third law is not in the book, so I went ahead and just left it out of the video. Everything being geared toward the test and whatnot. Anyway, my way of remembering these concepts, like I have basically like a little scenario I play in my head, and I'll go ahead and take you through it. And it's the thunderstorm. It'll all tie in a minute. But yeah, so like when I think about these 2 laws, I think about like a farmer that owns an apple orchard, right? Apple. And this farmer, he sweats, right? When he is working to pick the apples. So he's out, he's picking the apples, he's sweating, he's working real hard, right? That first exemplifies the second law of thermodynamics, in that his body is taking energy, right? Taking his stored energy, the energy that he has acquired from food, and it is transferring that to kinetic energy, right? So it's taking potential energy and it's changing it to kinetic energy, right? The kinetic energy of him doing bicep curls, apparently, while he should be picking apples. But yeah, so that's the first the example of the second law. And from there, the farmer, we're going to stay with the farmer here. The farmer's picking apples. He's sweating. He's taking his potential energy. He's converting it to kinetic energy. All right. So we're there. Now we're going to go with where the heat, that he expended while he was doing bicep curls rather than picking apples, where that went. And so that energy, right? It's moisture, the heat, it's all released, and it pushes moisture up into the air, right? Because energy, though, from his perspective, from the farmer's perspective, the energy's gone, right? It's not necessarily gone entirely. It did not disappear. From his perspective, it's gone, but the energy itself has went from him. And it's been transferred. It's been transferred to the moisture, to the sweat, to the air, right? And it's rising. Okay. From there, this happens with everything. This happens with trees and animals and moisture in the ground and all these other things. It all goes back up into the air, right? Like the deal we got going on here. Eventually, enough of it gets up there, enough of it condenses, and it begins to rain. Okay. Well, now without the energy having been transferred to get the water molecules, if you will, up into the atmosphere, it can't necessarily rain. I can't remember what that's called, but I remember I learned that when I was young. The water cycle. That's it. The water cycle. So it goes up. The heat and moisture. It goes up into the atmosphere where it combines with the heat and other moisture and causes rain. Okay, so it's raining, right? There's a thunderstorm going on. like you got a little rain action. Like our farmer's walking outside, and he's popping his umbrella. So back on the ground, right? I think this is messing up the light for the camera, so I'm gonna put it back. But just know that I would keep it if it wasn't messing up the light for the camera. So back on the ground, the farmer sits down and enjoys a nice piece of apple pie with his family during dinner. And during dinner, there just happens to be a thunderstorm going on. And so this energy that he released while he was working to pick apples, right? This energy is going back up into the atmosphere. It's coming back down, and it's watering those plants, right? So it's the rain falls from the sky and waters the apple trees in the orchard, and the apples are growing bigger, they're growing stronger, they're without this rain, right, produced from this energy. Your apple's not gonna grow, right? And the next day, the farmer goes back and starts the cycle all over again. So the farmer goes out and he's sweating. He's doing bicep curls again. Rather, this time he's actually picking apples. He's not doing bicep curls, but he's actually like reaching up. He's getting apples. He's doing pull-ups, and he sweats while he's doing this. Right? So he sweats. He releases more energy. So the energy that he released has made the entire cycle. Now he's going to eat it again, and it's just going to keep going. The actual conversion of energy, transfer of energy, it's much more complex than that. But that's just a way to help me remember it, and it's just a way to kind of exemplify the concepts. But yeah, I'm gonna take my apple, and yeah, it's been fun. All right, bye.